All right, so this is the video for 11.3, and we're going to talk about how to find the areas of regular polygons among rhombuses and kites as well. But regular polygons is the big one here. All right, so let's do a couple vocab, and then we'll get going with it. So a regular polygon is a polygon which has all congruent sides and all congruent angles. And we've talked about these before, so if that's like ringing a bell, that's a good thing. If not, just know that in order for a polygon to be regular, all sides have to be the same and all angles have to be the same. All right, so an apothem, this is different. This is something you probably haven't heard. This is also pronounced by some as an apothem. I've just always heard it as apothem, but you can hear it both ways. And an apothem is just the altitude that is drawn from the center of a polygon to any one of its sides. Okay, so say we have, pardon my drawing skills, they're not that good. Okay, here's the center of the polygon. So an apothem would be this right here that's perpendicular to the side. Okay, so this would be an apothem. The center of a regular polygon is the center of a polygon's circumscribed circle, and it's equidistant to each vertex. Okay, so if I were to draw this in a circle, okay, this would be the center because from here to all the vertices, and guys, that's not very good over here, would be the same. A radius of a regular polygon is just the radius of the polygon's circumscribed circle, so these would all be radiuses as well. So from here to the outside of the circle. And remember, this is just for inscribed polygons. And the central angle of a regular polygon is an angle formed by two radii, which is plural for radius, drawn to consecutive vertices. So this would be a central angle, this would be a central angle, this would be a central angle. And because these are regular polygons, meaning all sides are the same, all of these central angles would be congruent. All right, so the area of a regular polygon, okay? I never teach it this way. I always just teach it here. So the area of a regular polygon equals 1/2 times A times P, or area equals 1/2 times the apothem times the perimeter. Okay, so let's do an example here. All right, before we do an example, we need to figure out how to find the measure of some of these angles. Okay, so let's look at example 1 here. It says, in the diagram, ABCD is a regular pentagon. So that tells us that all these sides are the same length and all the angles are the same. Okay, and it's inscribed in circle F. So this is an inscribed pentagon in a circumscribed circle, okay, which means all these vertices are on the circle. Okay, so F would be the center. We want to find the measure of each angle. All right, so if I look at this, I'm going to draw all of these central angles here. So this would be a central angle, this would be, this would be, this would be, all the way around. And because this is a regular polygon, all the central angles are the same. So just to think, if I go all the way around in a circle, that's a total of 360 degrees. Okay, so I'm splitting that 360 into 1, 2, 3, 4, 5 central angles. So I could just do 360 divided by 5, which equals 72. So each central angle is 72 degrees. Okay, so I'm going to erase all this so we can just see it a little more clear. So this right here is 72 degrees. Okay, so when I put this apothem down here, it cuts that 72 into half. Okay, which means this is 36 degrees and this is 36 degrees. All right, so let's look at what angles I want. So AFB, that would be a central angle. We already said that's 72 degrees. Now AFG, we just said this apothem right here cuts that 72 in half, so this is 36 degrees. And then if I look at this triangle here, to find GAF, I know this triangle has a 36 and a 90, so I can find it by just saying 180 minus 90 plus 36, or 180 minus 126, which I believe is 54 degrees. All right, so let's look at example 2a, okay? This is a regular nonagon, and if you remember, nonagons have 9 sides. It's inscribed in a circle with a radius of 4 units. Find the area of the nonagon, okay? So it's a regular nonagon, so I can find the area as 1/2 times apothem times the perimeter, okay? So now if I can find the apothem and I can find the perimeter, all I have to do is plug it in. Okay, but it's a little more difficult than what it sounds like. All right, so what I'm going to do here is I'm going to look at this. The first thing I want to do is I want to find this central angle. I don't have the apothem or the perimeter right now. Okay, I want to find this central angle. And so if I were to draw all these, which I'm not going to, there would be 9 central angles. So I'm going to do like I just did. 360 divided by 9 is 40. Okay, so this angle right here is 40 degrees. Okay, I'm going to redraw this angle out here. K, J, and L. Here's my apothem. And the whole thing's 40 degrees. So if I cut it, that means this and this are both 20 degrees. Okay, so I'm going to cut it even more. I'm just going to look at, I don't know, I'm just going to pull out this top triangle. Okay, so, and I'm going to make it a little bigger so I can write things in it. K, M, L, and I do know that this is 20. I've already found that. And I do know the radius is given is 4. All right, so let's find the apothem first. And I'm just going to label the apothem A. Okay, so this LM right here is the apothem, which is what's down here. Now, I'm going to go back to using trig. Just because we're done doing it every day doesn't mean we can forget about it. Okay, so this is my adjacent side, this is my hypotenuse, so I can say that the cosine of 20 degrees is equal to my apothem over my radius. Okay, so 4 times cosine of 20 equals A, and if I plug that into my calculator, I get 3.76 roughly. 3.76. Okay, so my apothem is 3.76. All right, now I want to find my Km, because if I can find this part, it'll be the same as this part here, and then I can find all the way around because I know it's a regular polygon, which means all those sides are equal. All right, so that's opposite. So I'm going to use sine for this. So I could say sine of 20 degrees equals opposite over hypotenuse. So 4 times sine of 20 equals x. If I put that in my calculator, I get 1.37. So x is roughly 1.37. Okay, so that's just this little piece right here. That's this half. Okay, now I'm going to erase this so we can see this a little better. This piece right here, Km, is 1.37, which means this is also 1.37 because that apothem cuts it into 2. So each side of this regular polygon is 2.74. Okay, well, there's 9 sides in a nonagon, so I'm going to multiply that by 9. I get 24.66. So I can say that my perimeter is roughly 24.66. Okay, now I have my apothem and my perimeter. I can just plug these in now. So the area of this is 1/2 times my apothem, 3.76, my perimeter, 24.66. So times, I get my area is roughly 46.36 units squared. That should be your final answer. All right, let's do another example. Okay, area equals 1/2 times apothem times perimeter. Here, my apothem is given to me. My apothem is 6.5. Okay, now I just have to find my perimeter. So, in order to find my perimeter, I'm going to find this first. Okay, and if I look at this right triangle here, I can just do that by Pythagorean theorem. So 6.5 squared plus, I don't know, we'll call it x squared equals 8 squared. And if I put that into my calculator, I get x squared equals 21.75. And when I square root that, I get roughly 4.66. Okay, so this piece right here is 4.66. And if that piece is 4.66, this one here has to be 4.66. So that whole side there is 9.32. So this right here is 9.32. And if that's 9.32, then this has to be 9.32. This does, and this does, because it's a regular polygon. So I'm going to multiply that by 5, and I get that my perimeter is roughly 46.6. Okay, now I can just plug it in. A equals 1/2. My A is 6.5. My P is 46.6. And when I put that into my calculator, I get roughly 151.45. And that's units squared. All right, I want you to go ahead and try to do this one here on your own, and then we'll go over it. Make sure you draw the center, kind of make the central angle, right? Find out what that is, cut it in half, okay, do all that, and then use trig to find the apothem. So I'm going to let you do this, and then we'll go over it. All right, so if we go over this, you would get 360 divided by 10. Our central angle is 36, okay? And so when we divide that into two parts, so this part here and this part, it's 18 and 18. So I just drew this triangle down here, 18. This straight piece is my apothem, so I called it A. And then if we cut this in two, my 7 comes to 3.5 and 3.5. Okay, so I would use tangent. And if I solve for my apothem, I get my apothem is roughly 10.8, depending on how you round. Okay, so that's my apothem. Now my perimeter, I know this side is 7, and I counted all my sides. There's 10. So 7 times 10 is my perimeter. My perimeter is 70. And then I just plug it into this formula, and I get roughly 378.